In the next few minutes, we are going to break down a standard that operates right on the edge of survival. It's a set of rules that governs the most basic human act there is, breathing.
So let me start by asking you a question. How do you take a breath when the very air around you is trying to kill you, when it's full of smoke or poison or just has no oxygen at all?
Well, the answer isn't just courage, it's technology. It's meticulously engineered gear where every mask and every tank is a lifeline, and that lifeline is built to follow a very, very strict code.
And that code, that master plan for breathing in the worst places on Earth, is IS 10245 from the Bureau of Indian Standards. It's designed to make sure anyone who has to walk into danger has a way to keep breathing.
So here's how we're going to break it all down. We'll look at the overall framework and then dive into 4 different parts: the long haul, the first response, the tethered lifeline, and the emergency exit. By the way, if you are liking this video, subscribe to the ISO Automation Lab and press the bell icon below so you don't miss any of our explainers.
Now, what this table shows us is something really important. IS 10445 isn't some dusty old rulebook. It's a living, breathing document. I mean, look at the dates. Part 4 goes back to '82, but Part 2 was just updated in 2023, and Part 3 is already slated for revision in 2025. This standard is constantly evolving to keep up with new threats.
All right, let's start with Part 1, which we're calling the long haul. This is all about closed-circuit breathing apparatus. Okay, this is some seriously clever tech. Instead of just blowing your used air out into the world, this gear, a CCBA, actually recycles it. It grabs your breath, scrubs the carbon dioxide out of it, and then adds just a little bit of fresh oxygen back in. The best way to think about it is like a scuba diver's rebreather, but for use on land. It's a closed loop designed for one thing: maximum time.
And really, it's all about that duration. You use this gear when the job is going to take hours, not just a few minutes. We're talking about a complex mine rescue, deep underground, or cleaning up a gnarly chemical spill. These are long, tough jobs where lugging around a giant air tank just isn't an option.
Okay, so we've covered the marathon. Now let's talk about the sprint. This is Part 2, the first response. And this is the gear you've almost certainly seen before: the self-contained open-circuit breathing apparatus, or SCBA. Yep, if you've ever seen a firefighter, you've seen an SCBA. This is the absolute workhorse of emergency response, and its design is beautifully simple and tough as nails. You breathe in clean air from a tank on your back, and you breathe out directly into the atmosphere. No recycling, no fancy tricks, just a steady, reliable flow of fresh air. Now this number you see, 55 plus or minus 5 bar, this is absolutely critical. This is the pressure level that sets off the low air warning whistle on an SCBA. It's a loud, piercing sound you can't ignore, and it's designed to cut through all the chaos and tell you one simple thing: get out now. It's a beautifully simple, mechanical, life-saving feature.
All right, so what about a totally different kind of problem? That brings us to Part 3, the tethered lifeline, which covers supplied air systems.
I mean, think about it. What if you need to work in one dangerous spot for hours or even a whole day? A tank is going to run out, a rebreather might be overkill. So the solution is simple. Why carry your air at all? These Part 3 systems connect you with a hose to an air supply that's a safe distance away, giving you a virtually unlimited supply of clean air.
And this is where the standard gets super specific. It breaks it down into 3 types. Type 1 is the most basic. You literally pull the air through the hose with your own lungs, so you're limited to about 15 meters. Type 2 adds a blower to help push the air to you, which more than doubles your range to 36 meters. And then there's Type 3, which hooks you up to a high-pressure line for really heavy-duty industrial jobs like grip blasting.
And that brings us to our final category, and maybe the most intense one of all. Part 4, the emergency exit. This is for escape breathing apparatus. Now, you've got to understand this is a complete change in thinking. The other 3 types of gear are tools for working in a bad environment. An EBA is not a tool for work, it is a tool for survival, period. It gives you just enough air, maybe 10 or 15 minutes, for one single purpose: escaping a situation that has just gone terribly, terribly wrong.
And look, the standard itself puts it perfectly. The #1 design philosophy here is simplicity and speed. When everything hits the fan, you don't have time to mess with complicated buckles and valves. An escape set has to be something you can grab, throw on, and get working in seconds.
So, what are we seeing?
4 different problems, right? Needing to work for a super long time, needing to fight a fire right now, needing to stay put in one spot for ages, and needing to just get the heck out. And for each of those problems, IS 10245 gives us a specialized solution. And here it is, the whole system in a nutshell. Part 1 recycles air when you need maximum time. Part 2 gives you a high flow of air for firefighting. Part 3 gives you unlimited air through a hose for stationary work. And Part 4 is all about getting out fast. 4 problems, 4 perfectly designed tools. So why does all this matter? I mean, it seems like a lot of rules, right? But this isn't just red tape. A standard like this is an invisible guarantee. It makes sure that no matter who makes the gear, it meets a rock-solid, non-negotiable standard of safety. It's a promise to the people walking into danger that their lifeline will not fail.
And all this leaves us with a really fascinating question for the future. As our technology gets better, with lighter materials for tanks and smarter sensors that can monitor everything, what's next? What will the next generation of this life-saving code for breathing even look like? If you like this video, like, share, and subscribe to the ISO Automation Lab. We'll see you in the next one.